Objective 3. Compute and interpret probabilities using the empirical method. Probabilities deal with the likelihood that a particular outcome will be observed. For this reason, we begin our discussion of determining probabilities using the idea of relative frequency. Probabilities computed in this manner rely on empirical evidence, that is, evidence based on the outcomes of a probability experiment. Okay, so approximating probabilities using the empirical rule. Now, the probability of an event E occurring is approximately the number of times event E is observed divided by the number of repetitions or trials of the experiment. So the probability of event E is approximately the relative frequency of event E, which is equal to the frequency of event E divided by the number of trials of experiment. Now, when we find probabilities using the empirical approach, the result is approximate because different trials of the experiment lead to different outcomes and therefore different estimates of the probability of that event E occurring. Now, for this next example, we're using relative frequencies to approximate probabilities. Now, an insurance agent currently insures 182 teenage drivers, ages 16 to 19. Last year, 24 of the teenagers had to file a claim on their auto policy. Based on these results, the probability that a teenager will file a claim on his or her auto policy in a given year is the following. Well, we first need to find what is the frequency of that event E. Well, if we take a look here, we can say the following. We want to find the probability of that event E occurring. Okay? And so, what is the frequency of that event? Well, we can see that the probability of a teenager that will file a claim. So we're looking for the probability that a teenager will file a claim on his or her auto policy in a given year. Well, we can see here that 24 of the teenagers had to file a claim on their auto policy. So that means 24 is in the numerator. Okay, and then we got to divide it by the number of trials in the experiment. Well, that means how many teenage drivers were issued? Well, there were 182 teenage drivers. So we're going to take 24 and divide it by 82. So the probability of this event occurring is approximately 0.132. So we would then say the following. We would say that, so for every 100 insured teenage drivers, we expect about 13 to have a claim on their auto policy. Okay, and remember why? Because we have an answer of 0.132. When we convert this to a decimal, it's 13.2%. So that is approximately 13 out of 100. So that's why it's saying that for every 100, okay, over here, so for every 100 insured teenage drivers, we would then expect that 13 to have a claim on their auto policy. Okay, let's take a look at the next example. Building a probability model from a random process. Pass the Pigs is a Milton Bradley game in which pigs are used as dice. Points are earned based on the way the pig lands. Now, there are 6 possible outcomes when one pig is tossed. Now, a class of 52 students rolled pigs 3,939 times. The number of times each outcome is occurred and recorded in the table, which is down here. In part A, we want to use the results of the experiment to build a probability model for the way the pig lands. Now remember, we're given the fact of what the total is already, but we can find the total of this frequency by adding all of these up. Okay, but it's given because it told us that the amount is 3,939. And let's confirm that with our calculator. Okay, we're going to add up our frequencies. So 1344 plus 1294 plus 767 plus 365 plus 137 plus 32, and that gives us 3,939. So what does that tell us? Again, that tells us that the total in our frequency is 3,939. Okay? Now, we want to build a probability model, so we're going to create a new column called probability. So what we're going to do is we're going to take this amount of 1344 that represents a side with no dot, and that's going to be in our numerator, and we're going to divide it by the denominator to give us a probability of 0.341. Next, we're going to take the outcome of side with the dot was 1294. That's our numerator, divided by the total of the frequency is going to give us a probability of 0.329. Next, the outcome of Razorback was 767, and we're going to divide it by the total frequency to give us a probability of 0.195. Next, we're going to take the outcome of Trotter, which is 365. We're going to divide it by the total of the frequency to give us a probability of 0.093. The next outcome is Snouter, which is 137. So we're going to take that 137 and then divide it by the total frequency of 3,939 to get a probability of 0.35. Okay, and then last, we're going to take the outcome of Leaning Jawler, which is 32. 32 divided by the total frequency gives us 0.008. Okay, now recall, we can also turn our probabilities into percents, right? So we know that this represents 34.1%. We know that this one represents 32.9% because we're moving the decimal to the right twice. This is going to give us 19.5%. This gives us 9.3%. And this gives us 3.5%. And then this gives us 0.8%. Now remember what we said. This is out of a percent. So that means out of 100, we can say that 34 side with no dot is selected. 32, or this is approximately 33 out of the 100, the side with the dot is selected. So therefore, again, we want to make sure that we know how to interpret that. Okay? Next, we want to estimate the probability that a thrown pig lands on the side with the dot. So what is the side with the dot? Well, let's highlight that. Well, the side with the dot is that following, and the probability is 0.329. So therefore, the probability is going to be 0.329. Now, would it be unusual to throw a leaning jowler? Well, yes, it would be unusual because we would expect a leaning jowler about 8 times in 1,000 throws of a pig. Well, how do we figure that out? Well, let's take a look here. Okay, remember that we're saying that this is 0.8 out of 100, correct? That is the 0.8% of leaning jowler. Now, if we wanted to then remove this decimal, we'd have to move it to the right one time, which means we have to multiply this by 10 and then multiply this by 10. So 0.8 times 10 is going to give us 8, and then 100 times 10 is going to give us 1,000. So that's how they're getting the following result. They're saying that this is 8 out of 1,000. So yes, it would be unusual because we would expect a leaning jowler about 8 times in 1,000 throws of a pig, because that's what that would represent. Now, surveys are probability experiments. And why is that? Because each time a survey is conducted, a different random sample of individuals is selected. Therefore, the results of a survey are likely to be different each time the survey is conducted because different people are included.